That's a supervolcano, a continent killer, which erupts every 600,000 to 800,000 years, causing widespread devastation. Yellowstone, known for its geothermal activity, has recently experienced an alarming discovery. A strong earthquake shook the park one evening, disturbing the calm surface of Yellowstone Lake. Initially thought to be a minor tremor, it was actually the precursor to a series of increasingly powerful seismic events. Hundreds of earthquakes struck the park continuously for 2 days. Initial investigations suggest these events are not random. This could have catastrophic consequences. As the quakes persist, the fear of a catastrophic volcanic eruption grows. Is the massive earthquake swarm in Yellowstone a warning of an imminent supervolcanic eruption that could obliterate the continent? Join us as we delve into the terrifying discovery at Yellowstone that has residents fleeing for safety. Yellowstone's supervolcano, a dormant giant, has the potential to cause unimaginable destruction. The public and scientific community are on high alert due to the frightening prospect of such an eruption. Once praised for its serene beauty and natural wonders, Yellowstone is now a terrifying landscape. On August 29, 1870, a 30-year-old Army lieutenant named Gustavus D. ascended Mount Washburn, above the Yellowstone River, as part of an exploration mission in Wyoming Territory. From his vantage point, he noticed a section of the Rocky Mountains was devoid of mountains. The only hills in sight were distant, encircling a vast forest basin. There was only one plausible explanation: the Great Basin had once been the crater of an extinct volcano. The lieutenant was correct. Yellowstone is indeed a volcano, and not just any volcano. The oldest, most famous national park in the U.S. sits atop one of the largest volcanoes on Earth. However, D was wrong in one crucial aspect: Yellowstone's volcano is still very much alive. Supervolcanoes differ vastly from regular volcanoes. Some scientists describe supervolcanoes as producing extremely violent explosions, though there is no universally accepted definition. According to the U.S. Geological Survey, any eruption ejecting more than 240 cubic miles of pumice and ash in one event qualifies as a supervolcano. This is over 50 times larger than the notorious Krakatoa eruption of 1883, which killed over 36,000 people. Supervolcanoes can flatten mountains, wipe out life for miles around, and alter global climates, threatening species extinction. Although humans have never witnessed a supervolcano eruption, scientists have reconstructed the characteristics of such explosions. Initially, hot steam rises from the Earth's interior, melting rock just below the surface, forming a massive chamber filled with magma, semi-solid rock, and gases like carbon dioxide and water vapor. The ground above rises slightly as magma accumulates in the chamber over thousands of years. Cracks form around the dome's perimeter, releasing pressure and causing the gases to explode, similar to shaking and opening a soda bottle. As Bob Christensen, a U.S. Geological Survey researcher who pioneered Yellowstone volcano studies in the 60s, noted, when the magma chamber drains, the surface collapses, creating a massive caldera. Yellowstone's hotspot has caused numerous eruptions over 18 million years, forming eerie moonscapes like the Snake River Plain. The hotspot remains anchored in the Earth, pushed southwest by the tectonic plate above it. Have you ever felt an earthquake in Yellowstone? Even if you don't remember, you likely experienced a minor one, as the Yellowstone region averages 1,000 to 3,000 earthquakes annually. Most are too small to feel, but larger ones, like the 1959 earthquake, are notable exceptions. Yellowstone is among the most seismically active regions in the U.S., with activity felt across Montana, Wyoming, Idaho, Utah, Nevada, and Arizona. Yellowstone's iconic geysers and hot springs are a product of the park's underlying volcanism. Earthquakes often result from a mix of tectonic and volcanic forces, breaking rocks along fault lines and releasing energy as seismic waves. One positive aspect of earthquakes is they prevent features like Old Faithful from becoming dormant by keeping the plumbing system open. Without periodic earthquakes, mineral deposits could block the fissures and conduits that bring hot water to geysers and hot springs. Earthquakes in Yellowstone help maintain hydrothermal activity. Humans typically don't feel earthquakes below a magnitude of 3.0. Earthquakes of magnitude 4.0 or higher can damage structures, while those of magnitude 6.5 or higher can rupture the ground. In Yellowstone, seismic events over magnitude 6 are rare but do occur. The most famous and tragic Yellowstone area earthquake was the 1959 Hebgen Lake earthquake, a 7.5 magnitude quake that caused 18 miles of surface faulting and was felt across 600,000 square miles, decimating a popular campground during tourist season. On August 17, 1959, the Hebgen Lake earthquake, the second largest in the continental U.S. in the 20th century, struck. Even now, aftershocks from this major quake can be felt. Hebgen Lake, a large artificial reservoir, and the Madison River Canyon extend for miles. The Hebgen Dam, completed in 1914, sits at the canyon's head. Before the quake, the Madison River flowed through the canyon, flanked by steep slopes and rocky outcrops. The first tremor lasted less than a minute, leaving a vertical 20-foot wall of bare earth as the ground slid downwards. An enormous slab of loosely attached material broke away from the canyon's north-facing slope, crashing into the valley and creating a new natural dam downstream. As the Madison River flooded the canyon, it formed Earthquake Lake, engulfing trees and campers. The Hebgen Dam was in a precarious state, leading to widespread concern it might collapse. The night was filled with fear and chaos as families fled to higher ground to escape the rising waters. The earthquake resulted in 28 fatalities, with 19 more believed to be trapped under the landslide debris. Officials evacuated hundreds of casualties from the area. Following the quake, the Hebgen Dam was repaired, and roads and bridges were rebuilt. Yellowstone's thermal features also changed, including Old Faithful, which increased its eruption interval from 65 to 74 minutes. The Sapphire Pool hot spring in Biscuit Basin, previously quiet, began erupting over 200 feet high, destroying the basin's namesake formations. The world's tallest geyser, Steamboat, awoke from a 50-year dormancy 3 years after the earthquake. From Highway 287, the bare slope and waterlogged trees in Earthquake Lake are visible as reminders of the changed landscape. The largest Yellowstone earthquake since the early 1980s occurred on March 30, 2014, with a magnitude of 4.8. Yellowstone is equipped with a vast geological monitoring system, mostly undetectable to tourists. Earthquake swarms, or clusters of small quakes in a concentrated area, are common, with up to 2,000 earthquakes recorded in a single winter. This extensive monitoring helps scientists understand Yellowstone's subsurface geology. The last 3 super eruptions occurred in Yellowstone, with the most recent 640,000 years ago, 1,000 times the size of the 1980 Mount St. Helens eruption. The Yellowstone explosion's ash pillar reached 100,000 feet, spreading debris across the western U.S. to the Gulf of Mexico. Pyroclastic flows, dense and toxic, swept across the terrain, creating a hot mass that filled valleys. A more powerful eruption occurred 2.1 million years ago, forming a crater the size of Rhode Island, with another destructive eruption 1.3 million years ago. Each eruption had global effects, potentially causing volcanic winters. Some scientists believe DNA evidence shows a supervolcano eruption 74,000 years ago nearly wiped out humanity. Yellowstone's caldera, filled with lava flows and ash, is now mostly hidden by tranquil woodlands. The landscape, however, is still affected by past eruptions. The park's nutrient-rich soils support lodgepole pines, and its hydrothermal springs warm rivers, benefiting trout. Yellowstone's geothermal features, including half the world's geysers, are constantly changing, influenced by volcanic activity. Despite its volcanic origins, Yellowstone went largely unstudied until the late 1800s. In the 1950s, geologists like Francis Joe Boyd and Bob Christensen began studying the park's welded tuff formations, indicating past pyroclastic flows. They discovered 3 major eruptions, each leaving behind massive calderas. In 1973, Bob Smith noticed trees along Yellowstone Lake were submerged, indicating ground movement. His research revealed the lake's northern part had risen, suggesting volcanic activity. Smith published his findings, describing Yellowstone as a living, breathing caldera. Since then, Smith and colleagues have used various methods to study Yellowstone's underground volcanic system. They discovered a massive plume of hot rock feeding the magma chamber, causing the ground to rise and fall. This dynamic system continues to be closely monitored. The 2008 earthquake swarm led to apocalyptic rumors, but scientists reassured the public. While another eruption is inevitable, its timing and magnitude are unpredictable. Other significant volcanic events, like the 2022 Hunga eruption near Tonga, demonstrate the power and unpredictability of volcanoes. The Honda eruption produced record lightning strikes, revealing new insights into volcanic activity. Researchers continue to study these events to better understand and predict future eruptions.